Hello everyone and welcome to my channel IntelliFit Labs. I'm pretty excited today because this is the first video in my first playlist, and I thought why not talk about something that I already know a good deal about, but I'm also trying to learn more about as well. Um, it's gonna be a generative AI application tutorial. I'll be showing you how to build an application from ground up, brick by brick, and deploy it on the cloud. It's actually pretty simple, but there's a lot of work that goes into it, especially since we're going to build a production grade application instead of a mere notebook. Most generative AI tutorials stop at a notebook. They show you how to call a model, print a response, and then celebrate. But that's not how real systems work. Real generative AI applications need APIs. They need logging, observability, structure, and discipline. That's why in this series, we are going beyond experiments. We are going to build a production ready Python LLM application step by step from local development to robust APIs. Let's talk about how this actually works. In this series, we're going to answer a practical question. How do you turn a local LLM experiment into a production ready application? Not a notebook, not a demo, but a real backend that can handle uses, scale, log correctly, and survive in the real world. We'll start from first principles, how to structure a Python large language model stack. And then we'll answer questions like how to run models locally, how to run them in the cloud, how to expose the models through clean and robust APIs. We'll talk about observability, logging, and tracing, not just as buzzwords, but as tools that help you understand what your system is actually doing. Along the way, we'll introduce frameworks like FastAPI, LangChain, and LangServe. And more importantly, we'll discuss why and when to use them. We wouldn't we are not here to use those frameworks and technologies just because everyone else is using them in the real world. These tools and frameworks, they actually serve a purpose and they make life easier. They have a lot of pros associated with them, so that's primarily why I would be taking a look at them in this tutorial. By the end of the series, you should be able to take an idea from your laptop and confidently deploy it as a production grade LLM application. So let's start by building the foundation the right way. What are we even building in this series? Well, we're not just playing with prompts or notebooks like I mentioned earlier. We are building a real generative AI application, the kind that you could actually ship. The example app in this case, I'm going to call it Patient Scribe. Patient Scribe takes raw medical lab report text, sends it to a locally running LLM or an LLM running in the cloud, and returns a simplified explanation highlighting what's normal and what you should be discussing with a doctor. Along the way, we will cover APIs, logging, scalability, and deployment. Basically, everything that turns AI into ideas into software systems. Think of this as learning generative AI the way professionals build it and not the way demos show it. You're here to learn not how to just build an application, but also to ensure that it scales well and is performant in a system where there are a large number of active daily users. Before we proceed further, I wanted to make a quick note. Why healthcare? Well, because this particular industry, and also the financial industry for that matter, it forces us to think about clean architecture, data validation, privacy, and performance. So that's why healthcare. So what's next? Well, we're going to talk about frameworks for a bit. I'm not going to presume that everyone who's watching this video knows about frameworks, APIs, and whatnot. So for those of you who are not aware of what a framework is not magic. It's just structured help that answers questions like where does code go, how does data flow, and how do components talk to each other. In generative AI applications, frameworks become even more important because we are dealing with slower model calls, asynchronous workloads, and multiple uses. This is where APIs come in. The front end of any software application, or sorry, any generative AI applications do not talk to AI models directly. They talk to APIs, and APIs in turn decide what's allowed, what's logged, and what's safe. Without a framework, you'd be reinventing the wheel. With a good framework, you'd be assembling Lego models or Lego blocks with an intent. Think of this way. A framework is a scaffolding while you still get to build a house. So I hope that made sense about what a framework is. Now, a quick note on what an API is. API, as you all know, stands for Application Programming Interface. They are a set of protocols that decide how data is exchanged between software systems. Without fast API, or any similar framework for that matter, developers would have to handle all the boring plumbing themselves. Here's what that looks like. Um, you'd be manually parsing the URL to figure out which function to call, and you would have to handle all HTTP methods yourself. As far as routing is considered, you'd manually parse the URL, figure out which function to call, and perform request validation on your own. You would have to manually check every incoming request, and check for required fields, and check if all the fields are of the right type. You would also have to handle errors on your own. Every potential exception would need their custom try and accept blocks. But without fast API, you'll be basically building a mini framework for yourself, for every application that you build, and have to handle routing, validation, serialization, error handling, dependencies, and documentation, which is pretty boring when you start after the first one or two apps that you build. If you need to focus on these aspects, I'm afraid you wouldn't be able to spend time on application logic, which is what you need to actually spend time on. So fast APIs saves you hundreds of lines of boilerplate code and lets you focus on business logic, like and connecting your AI model to your logic. I'm sure many of you have also heard about Flask. Now, I don't mean to dunk on Flask, but Flask is simple, it's flexible, and it's great for small services. But it's synchronous by default, and that becomes a problem with AI workloads. Fast API, it's built differently. It's asynchronous first, uses Python type hints, and validates inputs automatically. Remember how we were talking about routing and performing input validation? Well, Fast API does all that for you. And what's more, it generates API documentation all on its own. So there's not a lot of heavy lifting done by you with respect to error handling, API integrations, and whatnot. This matters a lot for AI applications. Large language models take time. While one request is waiting for a model to respond, Fast API can handle others. It's concurrency without pain. That's why Fast API has become the industry standard for AI powered backend systems. So that was frameworks, and we had a look at what APIs are and we why generative AI applications go with Fast API instead of Flask. Now, we also need to understand what an ASGI is. Man, that's a lot of jargon for the first video in the playlist. I get it, but hey, here I am trying to make things easier for you so that you understand things clearly. I do not want you to just vibe code an application and go into an interview and show that application without understanding what you've even built. So, back to where I was. ASGI. ASGI, it stands for Asynchronous Server Gateway Interface. Most tutorials skip about what ASGI does. ASGI is what allows Fast API to handle asynchronous requests, streaming, and concurrency. In layman's terms, It's the layer that lets your Python application handles multiple requests at the same time without blocking. Without ASGI, every user would be standing in line waiting for the previous AI call to finish looking at their watch. This is where UVCon comes in. If you've already built generative AI applications on your own, I'm pretty sure you would have heard about UVCon. UVCon is a lightning fast ASGI web server implementation for Python. It acts as the bridge between modern asynchronous Python web frameworks like FastAPI and the network connection, which is your client or browser. FastAPI defines your application, but UVCon actually runs it. If if you like to if you like an analogy, FastAPI defines your application, and it's the blueprint, whereas UVCon is the engine. This stack is why FastAPI based generative AI applications scale cleanly under load. While one request is waiting on a large language model, the server can handle others instead of just sitting there doing um, nothing. Another example I wanted to bring up, which would probably make things easier for you to understand about the necessity of ASGI, is ChatGPT. Imagine you and your friends or classmates trying to access ChatGPT, asking it questions. It doesn't wait to complete the request from each and every one of you before moving on to the next request. It does everything in parallel. How do you think this is achieved? It's an asynchronous server gateway interface again. So there you go. Quick recap: we covered frameworks, APIs, and asynchronous server gateways interface. What's next? Well, I did want to talk about logging. And a lot of tutorials that I went through, I noticed that the developers they tend to use the native logging library in Python. Well, that's all right. But printing things to the console works until it doesn't. Logging is pretty important because this is where production applications live or die. Logs tell you what happened, when it happened, and why it failed. In generative AI applications, they are essential for debugging prompts, tracking latency, and understanding failures. While Python's built in logging is verbose, it's also easy to misconfigure and misses a lot of things. So that's why when I was reading articles on Medium, I came across LogGrew. LogGrew gives you clean, structured logs with almost no setup. In an asynchronous GenAI system, clarity beats cleverness every time. And if you can't see what you're developing, you can't fix it, man. Probably said by some developer over the years. But yeah, so that's why logging matters, and that's why we're going to set up LogGrew for beautiful and concise and, well, I wouldn't say concise, but beautiful and well correlated logs so that you know what request failed and where it failed. Um, while we're at it, I want to give a quick introduction to a couple of tools. Well, it's all part of the same ecosystem. It's part of the LangChain ecosystem. What is LangChain? Well, LangChain helps us to build generative AI logic as composable pipelines instead of messy function calls. While that is LangChain, LangServe lets us expose those pipelines as production ready APIs without writing glue code. You don't need to understand them just yet, but just know this: they would help us move from experiments to production grade systems. We'll build everything from scratch so nothing feels like magic, alright? Well, with that, I want to wrap things up. This is the roadmap I have in store for you. We'll start simple, then act structure, retrieval, logging, streaming, and deployment. You'll see how generative AI fits into real backend systems and not just notebooks. We'll be starting off with basic structure, configuration, and logging. We'll set up some endpoints like health checks, just so you have an understanding of how fast API works and how routing works. Phase 2 in this playlist is where the fun things start to happen. You'll configure a large language model locally, and we're going to use Ollama for that, and we'll try to we'll be going to integrate the model with our backend system. The next phase is where LangServe comes in, is where we would perform API orchestration to create API routes, and this is where you see the benefit of fast API and all the automated documentation that it generates. Phase 4 is about front-end development. While I wouldn't be going through how one creates a user interface for generative AI applications, I would definitely want to talk about session management and request separation. How do we get a large language model to not leak the requests and the details or the contents of another user request, of one user request to another, if you know what I mean? So that's why I would like to discuss about session management in detail. I wouldn't be going through how to create a user interface. Anyone can wipe code a visually appealing user interface these days, so that's there. Phase 5 is one of the more important topics in this series. We would be deploying the containerized stack to AWS and to Azure as well, because why not both, man? I've seen a lot of job ads. Some ask for Google or Text AI experience, some ask for AWS, and others for Azure. At the end of the day, I feel that if you know one well, you know them all, man. So let's deploy our application to two of the major cloud vendors, AWS and Azure, for global healthcare scalability. With that, I think we've come to the end of this video. I'll meet you guys in the next video where we would jump into code and watch all the beautiful things that can be achieved with fast API and large language models. Quick shout out to my friend Subhash, who got me into this journey of creating videos, and shout out to my Aunt Jackie and Aunt Alice. Till next time, fellas. See ya.